Hi everyone, in this video we are going to solve Cambridge O-Levels Additional Mathematics Paper 2 in a session October-November 2021 Paper 2-3. So let's start with the first question. Question number 1, in A part, on the axis draw the graph of this function and this function. So we have two absolute value functions. So let me start with the first one. Okay, so this is for the A part. If I use this function y equals to absolute of x minus 5, right? So first we need to find out the vertex point. So the vertex point is, we can get the vertex point to substitute the function inside the absolute sign equals to 0. So from here x is equals to 5, and when we substitute x equals to 5 we will get y equals to 0. This is a vertex point. So the vertex point is x is 5 and the y is 0, this point, right? Now let me take two other points, because this is an absolute function. You can take x equals to 4, 6, 3, 7. This is your choice, right? So let me take x is equals to 3. So when x is 3, y equals to absolute of 3 minus 5. That is equals to 3 minus 5 is minus 2. So we have absolute of minus 2 is 2, right? So for 3, this is 2, this point, right? And let me take x equals to 7. Y equals to 7 minus 5 is 2. So that is just 2, yes. And absolute of positive 2 is 2, right? So let me connect these points to get the graph for the first function. This and this. So we can say this blue one is the graph for y equals to absolute of x minus 5, right? Now let me do the second function. So we have a second function y equals to 6 minus absolute of 2x minus 7. So first thing is a vertex point. Vertex point is a point when we need to put this function under the absolute sign equals to 0. So from here the x is equals to 7 by 2. So when x is 7 by 2, the y value is equals to 6, right? So what is 7 by 2? 7 divides 2 in terms of decimal is 3.5. Between 3 and 4 we have 3.5, 7 by 2, and y value is 6. So this point is a vertex point of this function, right? Next we can substitute let me take x equals to if y is 0, let me substitute y equals to 0 and solving for x. So 6 minus absolute of 2x minus 7 equals to 0, right? So let me open the absolute. So to open the absolute we will get positive and the negative sign. So 6 plus minus 2x minus 7 equals to 0, and we have a negative sign as well. So let me solve the absolute first. So the absolute of 2x minus 7 is plus minus 2x minus 7, right? So if we do with the plus, we have 2x minus 7, and if we do with the minus, this is with the plus, and with the minus we have minus 2x plus 7. Right, now substitute over here with a plus, and minus sign is also outside this minus sign, so you have to change the signs. So 6 minus 2x plus 7 equals to 0, and from here minus 2x, 7 plus 6 is 13, 6 plus 7, that is 13, and shifting over here minus 13, x is equals to 13 by 2. This is my x-intercept when y is 0. What is 13 by 2? That is 6.5. Between 6 and 7, that is 6.5, this point. And we can also take with a negative sign as well. Like negative times negative is positive. So we have 6 plus 2x minus 7 equals to 0, the second equation, right? And here we have 2x minus 1 equals to 0, and x value is just 1 by 2. Right, now let me substitute x equals to 1 by 2, that is 0.5 between 0 and 1. Right, now let's connect the points to get the graph for the second function. Okay, so this green one is the graph for the function y equals to 6 minus absolute of 2x minus 7. Right. Now for the B part, use your graph to solve the inequality when this function, the blue one, is greater than the green one. Okay, so on what points the function is greater? This blue one is more than the green one. So as you can see, it has intersection at 2 and at 6. So all this blue one is more than this green one. So all the values of x, when they are, those are less than 2, the function is more, and more than 6, right? So for the B part, the answer is when x is less than 2 or when x is greater than 6, the inequality is satisfied. Now for question number 2, solve the following simultaneous equations. Give your answers in the form of a plus b square root of 3, where a and b are rationals. Okay, so we have given the system of equations. So let me use a method of substitution here. You have equation 1 and equation 2 we have given, right? So from equation 1 we can say x is equals to 3 minus y. This is my third equation, right? Substituting that value of x into my second equation. So 2 times of x, that is 3 minus y, minus square root of 3y equals to 5, right? Okay, now 2 times 3 is 6, minus 2y minus square root of 3y equals to 5. Now let me solve the y terms and the constant terms to the left side. So the y terms is, let me take y common. Minus y is common, so 2 plus square root of 3. And we have 5 minus 6, shifting 6 over here. So minus y is equals to 2 into 2 plus square root of 3 equals to minus 1. We can cancel the minus signs on both sides, right? And the y value we will get is equals to 1 over 2 plus square root of 3. So as you can see, in the denominator we have the rational expression, so we can convert it we can do a rationalization. Yes, so multiplying with the conjugate of the denominator, 2 minus square root of 3 divides 2 minus square root of 3. So y equals to 2 minus square root of 3, and in the denominator 2 square is 4, minus square root of 3 square is 3, so 4 minus 3 is just 1, so y equals to 2 minus square root of 3. This is the value for y. Now let me substitute this y into equation number 3. Yes, so x is equals to 3 minus 2 minus square root of 3. X is equals to 3 minus 2 plus square root of 3. So here x is equals to 1 plus square root of 3. So as you can see, we will get the values of a, b in the form of a plus b square root of 3, and a, b are the rationals. So 1 plus square root of 3 and 2 minus square root of 3 are the values for x and y. Question number 3, in A part, the curve has equation y equals to a cos bx plus c, where a, b, c are integers. Find the values of a, b, and c. Okay, so a is the amplitude, c is the equation of x's, and b we will get with the help of period, right? So first we need to find the equation of x's. So 1, 2, 3, 4, 5, 6, and the half of 6 is 3, right? So where is 3? 1, 2, 3. So this is the middle line. This is my equation of x's. Yeah. So this is the equation of x's. So we can say that the equation of x's c value is minus 1. And amplitude is equals to, you have 1, 2, and 3. So we have 3 units up and 3 units down. So amplitude is 3. And to get the value for b, we have to use the period. And this is a cosine curve, and the period of cosine is 360, or you can use 2 pi. So period is equals to 360 divides the b value, right? And to get the b value, we can do 360 over period. Okay, so what is a period? Period is one complete cycle from one maximum to another maximum. So it starts from x equals to 0 and ends at x equals to pi. So the period is pi. So 2 pi divides pi equals to 2. So the b value is 2 and a is 3 and c is minus 1. So we can say y equals to a is 3 cos b value is 2x and c value is minus 1. So this is the equation for the given curve. Now for the b part, another curve has an equation y equals to 2 sine 3x plus 4. Write down the amplitude. Amplitude is the absolute value of a. So here the amplitude is 2. This and for the second part, the period in radians. Okay, so this is a b value. We use this to get the period. So period is 2 pi in terms of radian over the b value. So this is 2 pi over 3. So period is 2 pi by 3. Question number 4 in A part, solve the equation, give your answer in exact form. Okay, so we need to convert the logarithmic form to exponential form. We have log base 6. So we have 2x minus 3 equals to 6 power 1 by 2, right? And from here, 2x equals to square root of 6 and plus 3. And x value equals to square root of 6 plus 3 divides 2. So this is a value for x. Now for the b part, solve the equation, give your answer in exact form. So we have a natural log. So using the property natural log of 2u divides u minus 4, because for subtraction we do division, equals to 1. Converting natural log to exponential. So taking exponential on both sides. So we have 2u divide u minus 4 equals to e power 1, just e. Right, so now we have to solve for u by doing a cross multiplication. So 2u equals to e times of u minus 4, right? And 2u equals to ue minus 4e, right? Shifting u terms to the left, 2u minus ue equals to minus 4e, right? And from here, taking u common, we have 2 minus e equals to minus 4e, and u value is minus 4e divides 2 minus e. So this is the value for u. Now for part C, solve the equation. So let me convert all the terms into the power of 3. Right. So this is 3 power v and 27 is 3 cube. So 3 cube whole power is 2v minus 5 and 9 is a power of 3 square. So 3 square is equals to 9, right? Let me simplify this further. 3 power is v divides 3 power. We have multiply 3 with 2 and 5. So 2 times 3 is 6v and 3 times 5 is 15 equals to 3 square, right? Now shifting the denominator powers to the numerator by reversing the sign. So 3 power v minus 6v and then plus 15 equals to 3 power 2. Okay, now the bases are same. We can compare the powers, and v minus 6v plus 15 equals to 2, right? So minus 5v equals to 2 minus 15. Minus 5v is from 15 take away 2 is minus 13, and v equals to 13 by 5. Question number 5 in A part, we need to show that the left hand side must be equal to the right hand side. So let me start from the left hand side. Let's take LCM, right? So cross multiplying, so we have cosecant x plus 1 and plus cosecant x minus 1, cosecant x minus 1, right, divides the product of cosecant x minus 1 and cosecant x plus 1, right? Okay, now in the next step we have to cancel plus 1 and minus 1 is just 0. We have 2 times of cosecant x divides cosecant square x minus 1. So here we have to use identity. So here we have given that cosecant square of a is 1 plus cot square of a, right? So let me write this down, that cosecant square x equals to 1 plus cot square x. And what is cosecant square x minus 1? Shifting 1 here, that is just cot square of x. Okay, so we have 2 cosecant x divides cot square of x. Right. So cosecant is a reciprocal of sine. So we can write it down as 2 over sine x. Right. And whole divides cot is cos over sine. Cos square x over sine square x. Right. So let me do the multiplying into numerator. 2 over sine x and doing a reciprocal of the denominator, that is sine square x divides cos square x. Right. So we can cancel this sine square with this sine, and we are left with 2 sine x over cos x into cos x. Right. So here we have 2 sine over cos is tan x and 1 over cos is secant x. That is exactly the same as our right hand side. Right. Now for the b part, hence solve the equation. This equals to 5 secant x for x is between 0 to 360 degree. So for whole this equation we got this, right? So it means that 2 tan x secant x equals to 5 cosecant x. Right. Now let me open all of them. So 2 tan is sine by cos. This is 1 by cos. And this is 5 into 1 by sine. Right. Okay. So if I multiply this sine over here, so we have 2, this is sine x over cos x. And this is sine x over cos x. And we have 5 on the right side. And we know that sine by cos is tangent. This is tan x, So tan square x, 2 tan square x equals to 5. And to get the value for tan square of x is 5 by 2. Right. And the value for tan x is plus minus square root of 5 by 2. So we have two cases, with a positive and with a negative, right? So let me solve this tan. So x value, x is tan inverse of square root of 5 divides 2. So, and the domain is we have given in terms of degrees. So you must calculate the value of x in terms of degrees. So let me check. My calculator is already in the degrees. So we have square root of 5 divides 2 is this, okay, and doing a tan inverse of answer, that is equals to 57.68, or we can say 57.7 degrees, right? Okay, now we have to do that tangent, two cases for positive and the negative, right? So let's see, tangent is positive in which quadrant and negative in which quadrant. Let me draw the xy coordinates, right? A, S, T, C. Okay, so tangent is positive in first and third quadrant and negative in second and fourth. So here we have the value for x, and here we have 180 degree minus x, here we have 180 degree plus x, and here we have 360 minus the value for x, right? Now the first case is when tan x equals to square root of 5 by 2, right? And the second is when tan x equals to minus square root of 5 by 2, right? So tangent is positive in first and third quadrant and in negative in second and fourth quadrant, right? And we got the value for x, that is 57.7. So in this case, the first case is for the positive one, right? And we know that tangent is positive in first and third quadrant. So we have the first quadrant, just the x value, that is equals to 57.7, and for the third quadrant we have to do 180 plus the x value. What is 180 plus the x value is 57.7, that is equals to 37.7, and this belongs to the domain between 0 to 360. 237.7, right? Now for the second case, tangent is negative in second and fourth quadrant. Second quadrant and the fourth quadrant. So for second quadrant, we have to do the operation 180 minus the x value. So 180 minus 57.7, that is 122.3. This is 122.3. This belongs to the domain. And for the fourth quadrant, we do 360, subtract the x value. So 360 minus 57.7. Sorry, 0.7. 302.3. So the values of x that satisfying the domain are 57.7, 237.7, 122.2, and 302.2. 302.3. Question number 6. It is given that x equals to 2 plus secant theta and y equals to 5 plus tan square theta. Now for a part, x plus y in terms of x. Okay, so y in terms of x, we have tan square theta over here. So we have to use the identity that 1 plus tan square theta equals to secant square theta. Right. So if we solve the secant square theta from here, you have x minus 2 equals to secant theta. Right. And x minus 2 whole square is equals to secant square theta. Right. So let's solve this. Y equals to 5 plus tan square theta is equals to secant square theta minus 1. Secant square theta minus 1, and we have secant square theta is this. Y equals to 5 plus secant square theta is x minus 2 whole square minus 1. Right. And to solve for y in terms of x, we have y equals to x minus 2 whole square plus 4. Right. Now this is for a part. Moving to part b, find dy by dx in terms of x. Okay, the derivative of this function. So dy over dx is equals to the power rule 2x minus 2. This is the derivative. Now for part C, a curve has the equation found in part A. So this is the equation of the curve, that is y equals to x minus 2 whole square plus 4. Find the equation of tangent to the curve when theta equals to pi by 3. Equation of tangent. So the equation of tangent is y minus y naught is equals to m into x minus x naught. M is the slope, or we can say the derivative at the point theta equals to pi by 3. X naught, y naught are the point. We have given the value for theta, but we have to solve for for x and y. Theta is given, solving for x and y. Right. So let's do it step by step. So when theta is pi by 3, what is the value for x? This is x and this is y. So let's do it. So we can say that at theta equals to pi by 3, x is equals to 2 plus secant of pi by 3. Secant is the reciprocal of cos, right? 1 by cos is the secant. And what is pi by 3? 180 divides 3 is 60. Cos of 60 is this. And reciprocal of 1, this is 1 over 1 by 2. So the reciprocal of 1 by 2, 1 divide answer. This is 2 plus 2. This is equals to 4. So x is 4. And what is y? Y equals to 5 plus tan pi by 3 square. Right. So pi by 3 we got is 60, right? Let me double check. Yes. And tangent of 60 is square root of 3. And the square of answer is, square root 3 square is just 3. And 5 plus 3 is equals to 8. So y value is 8. So when x is 4 and y is 8, so these are the points of x naught and y naught, right? X naught is equals to 4 and the y naught equals to 8. And m is the slope at the given point. When theta is pi by 3, x value is equals to 4, right? Just substitute over here. So now we have the equation of tangent is y minus y naught is 8. M value is 2 into 4 minus 2 into x minus x naught is 4. Right. Now we have to just simplify. So y minus 8 equals to 4 minus 2 is 2, and 2 times 2 is 4 into x minus 4. Right. So this is the equation of tangent to the curve when theta is pi by 3. Question number 7. The vector p has a magnitude 39 and is in the direction of this. The vector q has a magnitude of 34 and is in the direction of this. For a part, write both p and q in terms of I and j. Okay. So first we have the vector p, magnitude and the direction we have given. So we can say that the vector p is the magnitude is 39 times the the direction is minus 5i plus 12j divides the magnitude of the direction. 5 minus 5 square plus 12 square root, right? So here we have minus 5i plus 12j, right? And we have times by 39. Okay, so 5 square is 25, 12 square is 144 plus 25, and this is square root is 13. So dividing by 13, right? So what is 39 divides 13? This is equals to 3. So 3 is multiplying with minus 5i plus 2j, 12j. So 3 times 5 is 15. So the vector p is minus 15i, and 3 times of 12 is 36 plus 36j. This is a vector p. Now doing the same for vector q, that is this is the direction. Direction divides the magnitude of direction, 15 square plus 18 square, times we have given the magnitude 34. Right. So square root of 15. 15 square is 225 plus 18 square is 549, and the square root of answer is equals to, this is 18, sorry, this is 8. I messed up. Sorry, this is just 8. So 15 square plus 8 square is 64, and the square root of answer is 17, and 34 divides 17 is 2. So 2 is multiplying with 15i minus 8j. 2 times of 15 is equals to 30. So you have 30i, and 2 times 8 is 16j. So this is a vector q and this is a vector p. Now for part B, find the magnitude of p plus q and the angle in the this vector makes with a positive x-axis. Okay, so what is p plus q? P plus q. The vector p we just got is this, minus 15i plus 36j plus the vector q, that is 30i minus 16j. Okay, so when we add the two vectors, we add the component wise, I component with I and j component with j. So 15 minus 30, minus 15 plus 30 is minus just positive of 15, 15i, and from 36 subtract 16, we have 20j. So we need to find the magnitude of this is p plus q. Now the magnitude of p plus q is square root of 15 square plus 20 square. Right. So we have 15 square plus 20 square, and square root of 625 is 25. So we can say the magnitude of p plus q is equals to 25. Now we need to find angle this vector make with a positive x-axis. Right. For angle, let me draw this vector. So as you can see, the I component and j component both are positive. This is x component and the y component. So it is in the first quadrant. Right. So x is 15 and the y is 20. Let's say x is equals to 15 over here and the y component is 20 over here, and we have the vector this. Right, this is a vector. Now we need to find the angle the vector make with a positive x-axis. So this is a positive x-axis, right? This angle theta we have to find, right? Let me draw the right angle triangle here. Okay, so this is 15 and this is 20. So this is angle theta, the front side is opposite and this is the adjacent. So we have to use a ratio for tangent. So tan theta is opposite over adjacent. So 20 over 15, and the theta value is tangent inverse of 20 by 15. Theta is tangent inverse of 20 divides 15. Right. So 20 divides 15, and doing tangent inverse, you can do in degrees or radians. This is 53.1 degree. You can do in radians as well because we have no restriction in this question. 53.13 degrees. Question number 8. The diagram shows the part of the curve, this curve, and the straight lines x equals to 4 and 2y equals to 9x. Now for part A, find the coordinates of the stationary points on the curve. Coordinates means we have to find the xy coordinates, the x value and the y value, and stationary points we will get by putting the derivative of the curve equals to 0. So we have y, we need to find y prime or dy by dx, right? Okay, so let me write down y as we have 5 and this is x minus 1, power is minus 1 plus 2x. We can easily apply the power rule over here of that differentiation. So let me find the derivative. Dy over dx is equals to 5. The power is minus 1. Base function is x minus 1, power minus 1, minus 1, minus 1, and the derivative of x minus 1 is just 1. So dot 1 and plus the derivative of 2x is 2. So we have minus 5, x minus 1, power is minus 2 plus 2, right? Or we can say we have minus 5 divides x minus 1 whole square plus 2. So this is the derivative. Now let me substitute this derivative equals to 0 to get the values for x and y, right? Now for stationary point, we can say dy by dx is equals to 0. So minus 5 divides x minus 1 whole square plus 2 is equals to 0, right? So in the next step, we have minus 5 divides x minus 1 whole square equals to minus 2. We can easily cancel the minus signs on both sides and cross multiplying. 5 equals to 2 is multiplying with x minus 1 whole square, right? 5 equals to 2 is outside, opening the square is x square minus 2x plus 1 multiplying by 2. So 2x square minus 4x plus 2, right? Shifting this 5 on the other side. 2x square minus 4x plus 2, 5 shift to the right, it will become minus 5 equals to 0. So 2x square minus 4x and 2 minus 5 is minus 3 equals to 0. So this is a quadratic equation. We can solve it by using a quadratic formula. So x is equals to minus b, that is 4, plus minus square root b square. Minus 4 square is 16. Minus 4 times the a value times the c value, that is 24. Plus 24 divides 2 times of the a value, 2 times 2 is 4. 24 add 16, 40, and square root of 40 is 2 square root of 10. So 4 plus minus 2 square root of 10 divides 4, right? So let me take 2 common from the numerator and dividing with this 4. So we have 2 is common, 2 plus minus square root of 10 divides 4. So x is equals to 2 plus minus square root of 10 divides 2. Or let me further simplify it. So if this is 1 plus minus square root of 10 divides 2, right? So the x value is, let me do one by one. Square root of 10 divides 2, add 1, this is 2.58. And square root of 10 divides 2, 1 minus answer is equals to minus 0.58. Okay, so let me see. As you can see in the graph, only the positive x values define the part of this curve. So we cannot take the negative one, right? So we can only pick the positive one, right? So when x is this, what is y? So we have the curve y is equals to 5 over x minus 1 plus 2x, right? So let me substitute the x value here. So y equals to 5 over 2.5x minus 1 plus 2 times of 2.58. Okay. So 2.58 subtract 1 is 1.58, and 5 divide answer is equals to this, and then add 2 times of 2.58, we have 8.32 is the y value, 8.32. So we can say that the coordinates of the stationary point is 2.58 and 8.32. Now for part B, given that the curve and the line intersect at the point 2, 9. Okay, so we have given that the curve and the line, so this curve and this line intersect at the point 2, 9. So this point is 2, 9, means x value is 2 and the y value is 9. Yes, here the x value is 2 and here the x value is 4. Right, so the question is find the area of the shaded region. So this region is shaded. So let me find the area. Let's say this is area of a triangle, area A, and this shape is area under this curve between the point 2 and 4, right? So first let me find the area of this triangle. So area of a triangle is half base times height. Base is 2, 0 to 2 is just 2, and the height is from 0 to 9. Y is 9 over here. So 2 times 9 divides 2. We will get the area for the triangle, right? So area A is half base times height. 2 is cancelled with 2, so area A is just 9, right? Now let me do area B. Area B is area under the curve. So this is the integration between 2 to 4, right? So this curve and the integration is between 2 to 4. And we have a curve that is 5 over x minus 1 and plus 2x dx. So here we have 5 natural log of x minus 1 and 2 x integration is x square by 2, and the limits are from 2 to 4, right? So 5 natural log of x minus 1 plus x square, and the limits are 2 to 4, right? So let's start with the upper limit, that is 4. So 5 natural log of 4 minus 1 plus 4 square minus 5 natural log of 2 minus 1 minus 2 square, right? So this is 5 natural log of 3, 4 square is 16, minus 5 natural log of 1, 2 square is 4, right? And natural log of 1 is equals to 0, so we had left with 5 natural log of 3, 16 take away 4 is just 12. So this is the area B. Now let me find the shaded area, that is the sum of area A and area B. Area shaded is area A we just got is equals to 9, and this is area B. So in 9 add 5 natural log of 3 plus 12, right? So the answer is 5 natural log of 3, and 12 plus 9 is 21 plus 21. So this is a shaded area. Question number 9, an arithmetic progression has the first term A and common difference D. The third term is equals to 13. So we have given A3, and the 10th term is equals to 41. So A10, right? Now for A part, find the value of A and of D, right? So the term formula for arithmetic progression is an equals to A, the first term, plus n minus 1 into D, right? So we have given A3. So A3 is equals to A plus 3 minus 1 into D. So this is A3 is 13, A plus 2D, right? And we have given the 10th term. So A10 equals to A plus 10 minus 1 into D. A10 is 41. 41 equals to A plus 9. Sorry, 9D. This is my second equation and the first, right? Okay, so we need to solve the two equations to get the values for A and D. So let me subtract the two equations. A plus 2D equals to 13 is the first equation, and A plus 9D equals to 41 is my second equation. So let me subtract the two equations to get the value for D. So for subtracting, we have to change the signs, minus, minus, minus. So plus A and minus A is cancelled. This is just 0. From 9, take away 2 is minus 7D equals to 13 minus 41. 13 subtract 41 is minus 28. Minus 28 divide minus 7 is, so 28 divided 7 is 4. Negative is cancelled with negative. So the common difference is 4. So substituting this common difference into the first or second equation, we will get the value for A. So let me put into first. So A equals to 13 minus 2D. A equals to 13 minus 2 times of 4, that is 8. So A equals to 13 minus 8. So 13 take away 8, this is 5. So the first term is equals to 5. Now for part B, find the number of terms and value required to give the sum of 2555. Okay, so this is an arithmetic progression. Its sum formula is Sn equals to n by 2 into 2a plus n minus 1 into d. So we know that a is 5 and d is equals to 4, and the sum is 2555. So 2555 equals to n by 2, 2 times of 5 plus n minus 1 into 4. We have to solve for n, right? Okay, so let me simplify. 2555 equals to n by 2. 2 times 5 is 10 plus 4n minus 4. So 10 minus 4 is just 6, right? So here we have n by 2, 4n plus 6. Taking 2 common and cancel with this 2. 2 is common and we have 2n plus 3. 2 times 2 is 4 and 2 times 3 is 6, right? We can cancel the 2. So we have 2n square plus 3n, right? Let me rearrange. This will be a quadratic equation in a variable n. 2n square plus 3n minus 2555 equals to 0. So let me get the value for n by using quadratic formula. So we got the equation 2n square plus 3n minus 2555 equals to 0. So n is equals to negative of 3 plus minus square root. We have 3 square minus 4 times 2 times minus 2555 divides 2 times of a value, that is 2. Right, so n is equals to minus 3 plus minus square root. 3 square is 9, and what is negative times negative is positive here, right? 4 times 2 times 2, 555. We have 20,440 divides 2. Right, now the next step is n equals to minus 3 plus minus square root of adding 9, 2449 divides 2. And doing the square root of answer, we have 143. And is minus 3 plus minus 143 divides 2. Right. Now we have two values for n with a positive and negative, but we need to pick the positive one because number of terms never be negative. They are always positive, right? So here n is equals to minus 3 plus 143 divides 2, and n is equals to minus 3 minus 143 divides 2. Let's see. 143 subtract 3 divides 2 is 70. Sorry. 2 times 2. This is 4, not dividing by 2. So this is times by 2, right? So let me do it again. 140 divides 4. This is 35. And minus 143 minus 3 divides 4. That is minus 36.5. So we cannot pick the negative one. So the positive n value, we can say the number of terms required to give a sum of 2555 is 35. The number of terms must be 35. Now for part C, given that Sn is sum to n terms, show that S2k minus Sk equals to 3k into 1 plus 2k. Okay, so we already know that this question is same as arithmetic progression. This is the arithmetic progression, and the a and the d term we got from the first a part is 5 and 4, right? So let me open let's do from the left hand side. Left hand side says that S2k minus Sk, right? So let me write down Sn equals to n by 2, 2a plus n minus 1 into d. So a is 5 and d is 4. So 2 times 5 is 10. So this is n by 2, 10 plus 4 n minus 4, or we can say n by 2. Yeah, just keep over here. Yeah, so let's do it. We have 2k, so n is 2k, so 2k divides 2 into 2a plus 2k minus 1 times d, right? Subtract with k by 2 into 2a plus n minus 1 into d. N is k, sorry, k minus 1, right? Okay, so 2 is cancelled with 2. We have k. 2 times of a value is equals to 5, plus 4 is the d value, 2k minus 1, minus k by 2, 2 times of a value, plus 4 times of k minus 1. Right, let me simplify this further. We have k into 10 plus 4 times 2 is 8k minus 4, minus k by 2, 10 plus 4k minus 4, right? So we have k here, 8k, and 10 take away 4 is 6, minus k by 2, and 4k, and 10 take away 4 is 6, plus 6, sorry, and plus 6 because 10 is positive, right? So 8k square plus 6k. Here we have k square, 2 times 1 is 2, 2 times 2 is 4, minus 2k square, and 2 times 3 is 6, minus 3k, right? And k square is 8 minus 2, that is 6k square, and k terms are 3 and 6. So 3 take away 6, 6 minus 3 is 3, 3k, right? So here we can take 3k common, and we have 1 plus 2k. So as you can see, 3k into 1 plus 2k. So this is exactly equals to the right hand side. Question number 10, A part. It is given that f of x equals to this. Find the equation of normal to the curve y equals to f of x at the point where x is equals to 1. Right. So we need to find the equation of normal. So we have given x equals to 1. Let me find what is f of x. F of 1 is 4. 1 cube is 1 minus 4. 1 square is 1 minus 15 times 1 plus 18. Right. Plus 4 minus 4 is 0. 18 take away 15 is 3. 18 minus 15 is 3. Yes. So we have a point x, y, or xf of x is 1, 3. Right. So we have to find equation of normal. So first let me write down what is equation of normal. We have y minus y naught is equals to minus 1 over m into x minus x naught. So x naught and y naught is the point 1, 3. M is the derivative of this curve at the point x equals to 1. Right. So let's do it. F prime of x. So 4 x cube derivative is 3x square minus 4x square derivative is 2x minus 15x derivative is 1 and 18 derivative is 0. Right. 4 times 3 is 12x square. 4 times 2 is 8x minus 15. Right. So this is the f prime of x. Now we need to find that x is equals to 1. So what is f prime of 1? That is 12 minus 8 minus 15. So we have 12 minus 8 minus 15. This is minus 11. Right. Now substituting everything into the equation of normal, y minus y naught, that is 3, is equals to minus 1 over the m values minus 11 into x minus x naught is equals to 1. So we can say that the equation of normal is y minus 3 equals to 1 over 11 into x minus 1. Now for part B, do not use a calculator in this part of the question. It is also given that x plus a, where a is an integer, is a factor of f of x. Find a when it is a factor of f of x. It means f of a equals to 0. Right. Find a and hence solve the equation f of x equals to 0. Okay. Okay, so we need to find the a at which when we substitute that a must be an integer, we will get equals to 0. Okay, so this is the function is f of x, right? So when we put 0, we have 0, 0, 0, this is 18, not equals to 0. We did at 1, we will get 3. Same as minus 1. Let me check at minus 2. Is it equals to 0? So let me write down the function first. F of x equals to 4x cube minus 4x square minus 15x plus 18. Okay, now let me take a equals to minus 2. Okay, 4 minus 2 cube. You can check at 0, 1 minus 1, 2 minus 2 and check at what at what integer the function is equals to 0, the factor. Minus 4 times minus 2 square minus 15 times 2 plus 18. Right. So this is 4 and 2 cube is minus 8 minus 4, 2 square is 4 minus 15 times 2 plus 18. Right. So 4 times 8 is minus 32, 4 times 4 is minus 16 and 2 times 15 is 30. So minus 30 plus 18. Right. So let me check. We have minus, minus, minus and plus 18 over here. Is it equals to 0? First let me add all these terms. So sorry, it's minus 2 and this is plus. Let me do this. 30 plus 18. So we have 8 and 4, 48. Is the difference is also 48, 32 and 16. 6, 7, 8 and this is 4, 48. So 48 minus 48 is 0. So we can say that the integer a is equals to minus 2 and this is a factor of this function f of x. Right, so we can use a syntactic division to solve the equation f of x into the all the three factors because it's a cubic equation. Okay, let me apply this enthalpic division here. Now we know that minus 2 is a factor. Let me find the equation in terms of square, the quadratic equation. So the coefficient of x cube is 4, x square coefficient is minus 4, x coefficient is minus 15, and the constant term is 18. Just write down the coefficients here, and minus 2 is a factor, so minus 2 here. Bring the first term down, 4. 2 times 4 is 8, minus 8, minus 8 minus 4 is minus 12. 2 times 12, negative times negative is positive. 2 times 1 is 2, 2 times 2 is 4. So from 24 take away 15. 24 subtract 15. So 1 here and 14. 14 minus 5. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is 9, and 1 minus 1 is just 0. So we have 9. 2 times 9 is 18 with a negative sign, so we have 0. So these are the coefficients for the quadratic equation. So first factor is x plus 2. When you put equals to 0, you will get x equals to minus 2, and we have 4x square minus 12x plus 9. So these are the factors equals to 0, right? Now let me factorize the other form, because we have to solve the equation, right? Okay, so let me find the factors for this. It's a quadratic equation applying a quadratic formula. So we have x is equals to 12 plus minus square root 12 square minus 12 square minus 4 times 9 divides 2 times of 4. Right. The calculator is not allowed, so we have 12 plus minus square root. 12 square is 144. Okay, 4 times 4 is 16, and 16 times 9 we have to do. Let's do it. 16 times 9. 9 times 6 is equals to 54. 9 times 1 is 9, 11, 12, 13, 14, 15. 9, 10, 11, 12, 13, 14, sorry, 14. So minus 144 divides 2 times 4 is 8. So 144 minus 144 is 0, and square root of 0 is just 0. So this is 12 over 8, and 2 times 6 is 12, and 2 times 4 is 8, and 2 times 3 is 6, and 2 times 2 is 4. So the only x values we can say x is equals to minus 2, and x is equals to 3 by 2, or 3 by 2 is also equals to 1.5. So these are the two values of x that satisfy the given function f of x. So that was the last question of our paper. If you have any queries, please let me know in a comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.